Having seen how power is different in both DC and AC systems, let's bring up a concept that's called the RMS value, or the effective value. And so what the effective value is, it's the DC current or voltage that delivers the same amount of power as sort of the periodic current or voltage. And sort of as an easy way to understand this, like if we look at this DC circuit over here, the power across this resistor is just VI, or it's I squared R. And if we were to look in this this AC situation, the power is going to be 1/2 Im squared R. And so in both of these situations, there's a power consumed by the resistor, and that each has a certain measure of current. But what we want to say is that the effective voltage or current caused by this is going to be the same DC current that would give you the same amount of power in an AC situation. And because in our AC situation we have this sort of 1/2 value here, it's going to take more current in the AC situation to deliver the same as it would in the DC situation. And so for this particular circuit, we can say, if we're looking at the voltage experienced by this resistor, it's going to be, the RMS value is going to be the magnitude divided by square root of 2, and the current experienced by this resistor is going to be whatever that magnitude value is divided by square root of 2. So the RMS value is also called the root mean square value, so RMS, and there's a long integral with a root and a mean and a square in it that shows you the calculation. But the main point to remember that the RMS is going to be what would have to be delivered in a DC situation to get the same amount of power, and the relationship between the DC situation and the AC situation is that you would take whatever that magnitude of that current or voltage phase is, or wave. So if we're looking here at a voltage wave, so Vm, if I want to know what the effective voltage would be in a DC situation, I would take Vm divided by square root of 2, and that would tell me the effective voltage of experienced by that device. And it sort of makes sense because this AC wave is constantly oscillating, so you're never really actually at whatever that maximum voltage is before you immediately roll off and go to something else. So if you want to know the effective value experienced by the circuit, it would be the magnitude of either the voltage or current waves divided by the square root of 2.